Have you ever flown a great circle route and noticed your heading keeps changing? Well, that's not a mistake. It's something that we pilots call it as convergency. Now, what is convergency? Convergency is basically the angular difference between two meridians at a given latitude. Or you could also say convergency is the difference between the initial great circle track and the final great circle track. So I'll just show you an example over here. Like, notice this diagram. At equator, from equator, if you move all the way to north or if you move all the way bottom to the south, you notice all the meridians start converging together at the poles. Here, both the places. Okay. So if you remember the definition of Rhumb line which you had covered previously, Rhumb line is basically a line that cuts all meridians at a constant angle. So let's say you start your track flying from here at 45 degree. Rhumb line's purpose is to cut everywhere at 45 degree. In that process, what it does, it spirals towards the poles. Okay. Now next comes is a great circle. Great circle does not care about dissecting anything at any angle. The only function great circle does is you have to go from point A to point B at the shortest possible route, and it has to dissect the earth in an equal half. So in that process, if you were to dissect the earth in an equal half from this point, your great circle route will end up appearing somewhat like this. Let's say this great circle route. Now in this, notice the directions. Over here, the direction is slightly less. Now over here, if you notice, the direction is increasing. At this meridian, it's increased much more. Okay, so great circle does not fly a constant direction. The main function is to reach the shortest possible route. Okay, now how much to change the directions or the heading in a great circle? That is why we have convergency. Convergency helps us in that. Okay, now if you look at even the Mercator projection, like if I zoom in, even the Mercator functions exactly the same thing. If you draw a straight line, that is basically a Rhumb line. If you end up curving it like this, it ends up becoming a great circle route. Now over here, again the same function applies. Direction increases, direction increases, direction increases. Okay, now it can increase or decrease depending on what direction you're flying. Since you're in the northern hemisphere going to the right side, your direction increases. If you're in the north going to the left side, your direction reduces. If you're in the south, you're going to the right, your direction reduces. You're going to the left, your direction increases. Okay. Now, among all of this, there's one more thing that comes up, something that we call it as a conversion angle. Now, what is conversion angle? Conversion angle, simply put, is basically just the difference between great circle and the Rhumb line track. Just this angle. This is what we call it as a conversion angle. Okay. Now, why do you need a conversion angle? Let's assume you're flying a Rhumb line track. Flying a Rhumb line track of 45 degrees. And all of a sudden, you wish to fly a great circle track, especially for long haul flights, you need to fly a great circle track. So, how much to increase or decrease your track? That is what helps us in conversion angle to switch from a Rhumb line to a great circle route or from great circle to a Rhumb line route. Thank you.